Welcome back to Tech Talks Education. We are continuing with looking at atomic structure and chemical bonding. And we have already looked at what an atom is by definition. So let us now go and look at the structure of an atom. In this case, you must know that they can ask you to describe the structure of an atom with the aid of a label diagram. So we are going to draw, and then we also try to see how we can describe it using words. So let us look at the structure of an atom. An atom looks like this. Try to see what I'm shading here. And then let us stop at this. This one will help us to understand what we call an atom. Remember that we are looking at an atom which we have cut into two, and then we see what is found inside it. So, with an atom, we have got the central part of an atom, which is called the nucleus. Look at the spelling correctly. The nucleus is at the central part of an atom. So, inside the nucleus, we have got some particles. Those particles, we call them the subatomic particles. The particles found in an atom of an element. So, the nucleus containing protons, and then we also have what we call neutrons. Look at the spelling of neutrons. So the protons and neutrons are the subatomic particles, the particles found inside an atom. Remember that an atom is also a particle, the smallest indivisible particle of an element. And inside an atom, we also have some other particles. So we have seen that inside the nucleus, we have got the protons and we have the neutrons. Now, outside the nucleus, we also have some particles. And those particles, we are going to represent them by letter E. So, these particles are called electrons. And these particles, as you can see, these circles here, or the concentric lines we have drawn here, stands for the paths which these particles take when they are moving right round the nucleus. So these paths here, we do call them shells, or we can call them orbits, or we can call them energy levels. So, electrons move around the nucleus in shells, what we also refer to as being orbits or energy levels. So you can see that in each energy level we have got electrons. So the electrons are also subatomic particles, and they are found inside an atom. But the protons and neutrons, these are also subatomic particles, but we find them in the nucleus. The protons and the neutrons are in the nucleus. Meanwhile, the electrons are found outside the nucleus, and they move around the nucleus in shells or orbits or energy levels. So let us make a word description here that an atom has the central part, called the nucleus. Let me underline it, which contains positive particles, we are trying to introduce these subatomic particles one by one and their charge sign. So in this case, we have got positive particles called protons and neutral, that means chargeless particles, the ones bearing no charge, called neutrons. So, the protons and neutrons in the nucleus of an atom are called, together they are called nucleons. Look at the spelling of nucleons. So the nucleons are the constituents of the nucleus. That is the protons and then the neutrons. So we are done with the central part. Let us look at also the electrons which are found outside the nucleus. So outside the nucleus are negative particles called electrons that move round the nucleus in shells or orbits or energy levels. So outside the nucleus, we have these electrons here. I have represented using small letter E. So they move around the nucleus in what we call shells or orbits or energy levels. Now, importantly, we must remember this, that in a neutral atom, the number of protons and electrons are equal. Remember, we said that an atom is electrically neutral. Reason being, it has got protons, the positive particles, it has the neutrons, the neutral particles, it has the electrons, the negative particles. But we find that protons bear charges, positive charges, and then electrons bears negative charges. Only that the number of protons and electrons are equal in an atom. So if we have equal number of protons and electrons, it means that we have equal number of positive and negative charges in an atom, an element. And the reason, and in this case, the effect is that an atom will become electrically neutral in this case because of having the same number of positive and negative charges. That's the same number of protons and electrons. So this statement is very important and you don't have to forget them. So let me wind up with a simple table that shows us the subatomic particles, and we are going to see the charge of each subatomic particle and then the mass in this case of each subatomic particle. Briefly. So I hope that you have you are conversant with the structure of an atom, how it looks like in this case diagrammatically, and then this is the word description of the structure of an atom. So now let us look at this table containing the subatomic particles, and we are going to look at the charge on each subatomic particle, and then we also have to look at the mass of each subatomic particle. So let us look at particle, then we also look at the charge of each particle, and then the mass of each particle. And this one will catapult us to something else that we are going to see about an atom. Remember, we are still looking at an atom. So the particles we have are protons. So we have a proton, we have got a neutron, and then we have an electron. So let us look at the charge and the magnitude of mass of each of these subatomic particles. So a proton is a positive particle with a charge of +1. A neutron is a neutral charge, a neutral particle with no charge. So we say that the charge on a neutron is, on a neutron is 0. And an electron is a negative particle with a charge of -1. So remember that the number of protons in an atom of an element will give you the number of positive charges. If I have 11 protons, it means that I have 11 positive charges, and automatically I will also be having 11 electrons because the number of protons and electrons are equal. So 11 protons, that's 11 positive charges, and 11 negative charges gives me a total of 0 in this case. That's why we say that an atom is electrically neutral. So in this case, an atom is electrically neutral because of having the same number of protons and electrons as we have said here. Now let's go to the mass of each particle. A proton has a mass of magnitude 1. A neutron also has a mass of magnitude 1. But an electron has got what we call a negligible mass. So the mass of an electron is said to be, or is taken to be 0. Meaning that even if I have 100 electrons, we take their total mass to be 100 times 0, which is 0. So a proton has got a mass of magnitude 1, and a neutron has got a mass of magnitude also 1. So we can see clearly from here that it is a proton, or it is the number of protons and neutrons that gives us the mass of an atom, as we are going to see later on. So this is a simple table that shows us the particles in an atom, the subatomic particles, the charge of each particle, and then the magnitude of mass of each particle, which we are going to use later on. Please do not forget this. So we saw the diagrammatic expression, or the diagram of an atom, what it consists of, and this is what we wrote down as our word description of what we have as being the structure of an atom. It has got the central part, which is the nucleus, and it contains positive particles called protons, and then negative particles, and then neutral particles rather called neutrons. Then the protons and neutrons, we say that, which are found in the nucleus together, they are called nucleons. And then outside the nucleus, we have got negative particles, which are called electrons, and they move around the nucleus in different shells or orbits or energy levels. So we have finally here that in a neutron atom, the number of protons and electrons are the same, and that one makes an atom to be neutral in this case, because the positive particles and the negative particles simply cancels because they have got equal number of charges. In this case, if at all I have 10 protons, it means I have 10 positive charges, and then 10 electrons, 10 negative charges, they simply cancel, and atom remains neutral. So this is the structure of an atom, and this is Tech Talks Education. Thank you for watching.